In the video before the previous one, I briefly discussed about the encoder. In today's video, I'd like to talk about multi-head attention. If we look at the diagram, this is the encoder. And in today's video, I'd like to talk about this multi-head attention, which is one of the important component of the model, which is also one of the component differentiate from old models like the one in RNNs. And what is its function? It would enable models to focus relevant parts of the sequence, or it would help model to understand relationship between each words or tokens so that it would understand the context of the sentence. So it's called multi-head attention, but the simpler version is called scale dot product attention or self-attention. So in multi-head attention, you'd have multiple of this component. So it's just whether you'd have multiple of this thing or only one attention. So that's the only difference. But it's better to have. Usually now these days you'd have multiple heads because so that you could divide each processes into each heads, and each heads runs simultaneously, individually, hence processing simultaneously. So the training time would be shorter, and training it would be faster to complete. This just differentiate from old models like RNNs, which only can process input sequentially. They can't process in parallel. So yeah. And how would you implement this? First, you have to create matrices called QKB by taking. So I've got my custom function, and just ignore this mask thing. This would transform this multi-head attention into masked multi-head attention, which I'm not going to discuss in today's video. And so this is how you'd make Q, K, and B. I passed the weights, and the weights are declared here. So this is weights for Q, K, and B, and I've got another weights which is in the end of the function. These stands for query, key, and value. And let's say, for instance, the input was sentence, and the sentence was this. So in this sentence, the query would be sat, and the key would be cat. And the sat query is looking for a word relevant to itself, and cat key has to offer that relevant word. to set or to key. So it's just essentially the query is looking for a relevant word and key offers that relevant word. And if we take, so we compute what known as attention scores by matmul Q and K. The dot product between cat and sat would be high. The attention score between sat and cat, because they're relevant. We update weights so that the attention score would be high in each backpropagation computation. So the Q would have this shape and K would be this shape because it's transposed. And each row represents the word, like the word, the cat, sat, and so on. And in this example, the inside the Q matrix, the sat would be in the third row of the Q matrix, and because the K is transposed, the word cat is in second column. It was in second row, but because it transposed, I think, so it was in second row. If you transposed, it would be in second column instead now. And if we multiply Q and K in here, we would get 20 by 525. And so I said attention score between sat and cat would be high. So if we dot product second column, second row and third row and second column, third row matrix of the third row of the third row and second column, the value for third row and second column for this 25 matrix would have high value. And if we apply softmax to that, this value would have a value close to 1. And if we take matmul with this V, which holds the actual words, so I think this V holds, but this V is also these QKV are almost all the same because it was created by using the inputs, but one day differs by how which weights it was used. Anyways, so this 25 attention weights holds the score. Each token it holds a score. A token should score. It holds a score. Each token should attend to the values. So this third column, the set should attend to. So if we matmul these two, if we dot product, this X goes to all these rows, which means the set was in third column, third row, and the cat is in second row. And if we dot product, this would multiply by x, which means the set should attend to cat because they are relevant. Hence, self-attention or multi-head attention. I mean, we just compute how relevant each words are and actually get that word by multiplying that with actual information at the end. So this is like the best explanation I could do for this attention. So obviously I group number heads. So in fact I have to fix this so that it would run simultaneously, which I haven't done yet. So let's say I chose number of heads as 4. This runs through 4 times, and at the end it would after all the heads are finished, after all the heads are done processing inputs, I concatenate all the results, and I also take memo with another weights I showed you before, and I return the output. So, and this is like I said, this is the best explanation I could do. I mean, so this is related to mask things, so you could just ignore this. And I didn't mention, but before you compute attention scores, you stabilize it or scale it by dividing by square root of number of heads. But this is it's not trivial, but the main idea was the thing I talked, like this thing. Yeah, so I think this is for today's video, and maybe in next video I may talk about masked version of this multi-head attention. And I'm not really sure if I'm going to continue making this type of videos where I explain each essential topics, like important components like multi-head topic about multi-head attention, because I've started a new project and I maybe just like the title of the video says yeah, I think I would just do devlog type video from now on, where I just talk about what I've done in like past week, but I'm not really sure. Yeah, so I think this is it for today's video, and thanks for sticking to the end of the video, and as always, thanks for all the supports. So yeah, thanks.